Right, on this particular question, we have to remember that if we have a vertical height and a slant height like that, we can use the Pythagorean theorem because the radius and the vertical height meet at 90 degrees. Right, so we can write here h squared plus r squared equals 15 squared, which is 225. Right, let's remember that. Okay, now we go back to the formula of volume. Right, it's 1/3 pi r squared h, the formula here. That's what we're going to make use of. Right, so if we compare this with that, we will notice that r squared has been replaced by that there. Right, so in other words, what they've just done is they've taken 15 squared, which is 225, and they have subtracted h squared to get r squared, which is completely correct according to Pythagoras. Alright, so the volume for our cone is going to be 1/3 according to this formula down here, 1/3 pi r squared h. So we have 1/3 pi. Then instead of r squared, we are going to put this here. Right, that's 1/3 pi r squared times h. Right, so what that does is this. We get v equals 1/3 pi, then bracket 225 minus h, 225 minus h squared, then we multiply by another h, right? So this will simplify to give us, that there. Right, so it gives us 1/3 pi bracket 225 h minus h cubed. Right there. Right, that's how we arrive at that formula there. Right, given that h can vary, find the value of h for which v has a stationary value. Right, okay, so this is a differentiation question. What we're actually looking for is dv dh. We're actually looking for dv dh. And dv dh can be found by saying 1/3 pi. This is a constant, right? Inside the brackets we had 225h, so if we differentiate 225h, we end up with 225 only. 225 minus, we had h cubed. If we differentiate that with respect to h, we have 3h squared, like that. Now, when v has a stationary value, this expression will be equal to 0. Right, so we start dealing with this expression. Right there. Right, so if it's equal to 0, we can divide throughout by 1/3 pi, which means this goes, and we'll be left with this equals 0. Right. Next, we solve this equation for h squared, which gives us h is equal to plus or minus the square root of 225 over 3. Right. This gives us the values of h for which v has a stationary value. Right. Next, we may want to find, it says here, determine showing all necessary working the nature of the stationary value. So this is what we do next. Of course, since h represents the height of our cone, h cannot be negative. So we can say that h is equal to the positive square root of 225 over 3. Right, this is our value of h. Right, then next we have to find the nature of the stationary point. So d squared v dh squared equals, this is what we have to find and determine whether it's positive or negative, so that we know the nature of our stationary point. So we get this when we differentiate dv dh with respect to h. We get this. Right, now since h is positive, this expression here is always negative, right? Which means d squared v dh squared is negative. And when d squared v dh squared is negative, it means our turning point, is a maximum. What this means is that our turning point, this means turning point is a maximum. Turning point is a maximum, turning point. Right, so having done that, we have answered this part of the question here.